So how's everyone doing this afternoon?
Good, thanks.
Good. So we got kind of a small audience. It's good. If you, the nice thing about a small audience is that you're welcome to interrupt me because, you know, we can kind of go with the flow with the questions. So if you have questions during the talk, just raise your hand and I'll answer them. I have a slide at the end that says questions, but we don't have to wait till the end. So feel free to jump in, just raise your hand. And if I deign to acknowledge your presence, then I'll answer your question. My name is Guy Royse. I'm a developer advocate at Redis. There are three things on this slide that matter. One matters to my boss, one matters to me, and one matters to you. The thing that matters to my boss, any guesses? That Redis logo right there. One of the things that we run into with Redis a lot, and well, quick show of hands, who here has used Redis before? Okay. So a lot of you. How many attended Steve's talk? He's sitting right here to call him out this morning. Good. This should be a decent follow-on to, well, maybe not a decent follow-on, but this should be a suitable follow-on to what he did. I will not claim that my talk is going to be decent. But one of the things that we're trying to do is a lot of people see Redis as it's a cache. You can get things and set things. And there's a lot more capability that's under the covers there. And so we're just trying to let you know, hey, Redis does more stuff. So this is a talk about some of the more stuff that Redis does. So that's the Redis part that my boss cares about. I kind of care about that too, honestly. The thing that I really care about, though, is that Twitter ID right there. I measure my sense of self-worth based on how many Twitter followers I have. So please help feed my narcissism and give me a follow on Twitter. If you do, I think my pocket will buzz. I didn't put my phone in airplane mode. Let me do that really quick. There we go. Now you can say bad things about me on Twitter while I'm giving the talk, and I won't know it because that's easier. So, and the thing on this slide that you care about is that GitHub URL right there. So all the code and the examples and all the stuff that I'm going to show you today are all out there on my GitHub at github.com/GuyRoyse. So that's really the important part, isn't it? So, in addition to being a developer advocate, I am also an enormous fan of Bigfoot. Who likes Bigfoot? Everyone's like, I mean, it's kind of fun, right? But I've always felt like just a connection, a kinship. There's just something about this large, hairy humanoid that's running around in the woods that just feels, I just have a strong sense of relation to. And, well, I have a confession to make. Bigfoot is my father. I haven't seen him since I was a kid. He went out for milk and cigarettes. He never came back. And this is the last picture I have of him. And this is me eating a turkey leg. And so I've been trying to find him for decades now. And so when I started in my quest to find my father, the first thing I did was I started doing research, like, hit the stacks, find all the stories from the hitting press, cutting edge press here. This is I don't know if you get this newspaper in the UK. It's called Weekly World News. It's got big things like about, like UFO, Elvis love children and stuff like that. It's got all kinds of really wacky stuff on it. It's really funny. This is from that. And it turns out they're way more accurate than you think because that is a picture of me as a child in my whitey tighties, running through the woods with my dad. We had stolen some food from some picnickers, and it was a good day. I remembered it was kind of a warm day. We were somewhere near the Ohio River in my home state of Ohio, not too far from Cincinnati. We might have been in Kentucky. I'm not sure, but yeah, it was a good day. But I hit these stacks. I found lots of articles like this, lots of accounts of this, but they didn't help me find my dad. They just told me about my past. And so, well, I thought maybe I should go to the investigators at the Discovery Network. We don't always find Bigfoot, but when we do, we don't. This show is fantastic. What I love about this show is, they go out in the woods, they try to find Bigfoot. And they've got 3 true believers and a skeptic. Any guess who the skeptic is? I'll give you a hint. She has a look on her face that says, "Oh my God, what have I done with my career?" They weren't able to help me find my dad, but the guy on the right is the founder of an organization called the Bigfoot Field Researchers Organization. They have a website, founded in 1995. This website, clearly founded in 1995. It's not behind an Angel Fire domain name. It actually does. It's at bfro.net. And they are the only scientific research organization exploring the Bigfoot Sasquatch mystery. And most importantly, they have a comprehensive sightings database. And I'm like, ooh, database? I'm a developer. I know how to use databases. But that's not what they meant. What they meant was, we've got a bunch of web pages with accounts of Bigfoot sightings on them. Like, this is not data in the sense of something I can query. But fortunately, the internet has everything. This is Tim Renner. He likes weird data. And he has gone through on the website data.world and screen scraped the Bigfoot Field Researchers Organization's.net's website to create a CSV file with all of their sightings in it. That's data. He's also done haunted places in the United States, and he's done UFO sightings in the United States as well. And so the UFO data is, he uses this data to do all sorts of interesting data science projects. And so the UFO data, he wanted to find out, he just did some basic analysis and wanted to find out, just kind of look at the data, learn about it. Any guess in the United States what the most common day for a UFO sighting is? It's Independence Day on the 4th of July because everyone's up looking at fireworks. It's like, is that a UFO, son? No, it's a firework, Dad. Now, the second most common day was New Year's. The other thing he found is that most UFO sightings tend to occur within 50 miles of a U.S. airbase. Shocking. But what he did with the Bigfoot data was really fun because he was trying to find Bigfoot too. And this is why this is a good guy of mine. Good guy I know. And so he took all of the Bigfoot sighting data that he screen scraped, and he did a clustering algorithm on it to find natural groupings of these sightings. And he got this nice map of the United States and Canada, and it's showing these clusters of sightings, and he doesn't understand what they mean. They don't seem to correspond to everything. And then he puts a vegetation map over it and concluded that you can find Bigfoot in the woods. So, data tells us useful things. But I thought I could load all this Bigfoot sighting data that he's gathered into a database and start doing some queries and maybe find my dad. Maybe I can find the report that matches up to that event, when we stole the picnic baskets that the Weekly World News grabbed. And so the data is really fun. It's pretty basic, but you've got an ID for that report. The ID is it's a report number, report number 8086. It's got a date, January 15th, 1958. Has a title, which is exactly what you think it is. In this case, a series of large human-like footprints are found on a farm near Wayne National Forest. That's actually in Ohio, where I'm from. The observed, this is the eyewitness account of that Bigfoot sighting. And so, while during some yard chores, we noticed a series of tracks going into the hollow on our property. Upon examination, and then they go in and talk about their encounter with Bigfoot. Bigfoot sightings, you might not know this. Are you familiar with how UFOs are classified by Close Encounters of the First, Second, and Third Kind, as made famous by Steven Spielberg and mashed potatoes? Bigfoot sightings have a similar thing. They have Class A sightings, Class B sightings, and Class C sightings. A Class A sighting is, I saw Bigfoot. He was right there. A Class B sighting is, I found evidence of Bigfoot, like a really large footprint, or maybe I heard some weird noises. And a Class C is my favorite. It's, someone told me they saw Bigfoot. Technically, aren't these all Class Cs? It also has the county and state within the United States that it happened in. So this one happened in Noble County, Ohio. And it's got the latitude and longitude. And the location details are sort of like they're the extra details. Here's the latitude and longitude, but you want to go down this dirt road and turn right on the second right and that kind of stuff. So this is the data the BFRO gathered. Tim went ahead and put dark sky weather data on top of it. He was thinking maybe like moonlight might affect, like the phase of the moon might affect Bigfoot sightings, or maybe if it was foggy, that kind of stuff. And so we've got a bunch of weather data here. Unfortunately, it's all in freedom units and not in Celsius. So, but I'll say that 34 degrees Fahrenheit is cold. It's like 1. So, although funnily enough, the temperatures are in Fahrenheit. The precipitation is in millimeters per hour, which is not what we do in the United States. And but then the visibility is measured in miles. So I don't know. Measurements are hard. So this is all mixed up. This is the data that I have from Tim. And I've decided that I'm going to load all this data into my favorite database of choice, Redis. And there's a lot of ways that I could represent this data in Redis. And Steve's talked about some of this in his talk this morning if you were there. But I'm going to touch on them super quick. I'm going to talk about 4 data structures in 4 minutes. So the 4 data structures we're going to talk about. Number 1, strings. This is the one that if you've used Redis, you've definitely used. You call get, foo, bar, or you say set foo, and then, or set foo to a value, and then you get foo. So here I'm setting a Bigfoot sighting number 8086 classification to class B, and a Bigfoot sighting 8086 state Ohio. And then I can go and get those values out. So you just call set and get. Strings. It's just a big blob of data, or a clob. There are lists. These are doubly linked lists in Redis. Lots of times people will use these as queues. And so here, my little example is I'm pushing things onto the list. They're new Bigfoot sightings that we've found, perhaps, and that we want to process. And so we push them onto the list, and we push the next one onto the list, and then we can pop them off the list. And so here I'm using lpush and rpop to do that. But they're just linked lists. You know, the best way to think about Redis, honestly, is I like to think of it as networked memory, because it's really just memory. But more than that, it's, you know all those data structures you learned about in data structures class in college, assuming you took one of those like I didn't. Redis is all of those data structures with a wire protocol in front of them. And so that's really what Redis is. It's networked memory. And so these strings and these lists are just those data structures. The sets, it's a set. I know Steve talked about this because I poked my head in and he talked about the SAD command, the set add. So a set is a set in a mathematical sense. You can do unions and intersections and that sort of stuff. You can call SAD to add, set add to add things. And then you can check to see if something's a member by saying set is member, sys member. And so here I'm adding to a set IDs of Bigfoot sightings that happened in Ohio and ones that happened in Kentucky. And then I'm asking, did this one happen in Ohio or not? So is the string 8086 in the Bigfoot sightings by Ohio set? And then a return a 1 or a 0 if it is or it isn't. And last but not least, and the one that's really going to feature today, are hashes. Hashes are exactly what you think they are. They are dictionaries. They are hash tables. They are associative arrays. They're name value pairs. It's a hash table data structure that sits in a Redis key, and then it has fields within it. And so here I'm using the hset command to set the classification, the state, and the state on a particular Bigfoot sighting, and then I'm querying out the classification. So make sure you write all this down. There's going to be a quiz afterwards. Our data will be represented as hashes. So here I'm calling hset Bigfoot sightings 8086. And then all those fields I talked about when I was explaining the data, I'm just setting them. So I'm setting the latitude, the longitude, the classification, all those fields. So that's how you can load a whole bunch of Bigfoot sightings into Redis. But how do I get them out? How do I find them? That's really the hard part. It's easy enough to put things in there, but how do you pull them back out? How do you find them? Well, I've sort of got 3 ways to do that. The easiest way is just to get them. You call hgetAll on a hash, and then what you'll do is you'll do this sort of this name spacing pattern. So I've got Bigfoot sightings. So anything that starts with Bigfoot sightings is a Bigfoot sighting. And then I'll just put my ID at the end of it. And so if I know the ID for the record I want to find, I can just go look it up. I can go get it directly. Easy peasy. But not super useful. I don't want to find I don't have all them all memorized. I don't know all these numbers. I want to find Bigfoot sightings that are in a particular state or in a particular county or near a particular place. And so a common way to do this is to build your own indices using sets. And so what you do is you build a set for every value that a key might have that you want to index. So here I've got a set for all the Bigfoot sightings in the state of Ohio. So Bigfoot sightings by state, Ohio. And then I would have one for Bigfoot sightings by state, Kentucky, and Bigfoot sightings by state, West Virginia, and Oregon, and Hawaii. I'd have 50 of these, one for each state. And then that set contains just the IDs of those Bigfoot sightings. So if I want to get all the Bigfoot sightings in Ohio, I just say, give me all the members of the set. And I can do the same thing for all my classifications, Class A, Class B, and Class C. And they all just return these IDs. And then I can query them using the setMembers, the smembers command. And so here, if I want to know all the Bigfoot sightings in Ohio, then I can say Bigfoot sightings by state Ohio. Just get them all. They're just in a list. They're just in a set. I just pull them back. But the cool thing is that the set operations in Redis include things like unions and intersections. So if I want to get, say, Bigfoot sightings in 2 different states, I can say I want all the ones that are in Ohio and Kentucky. So I can union those sets and get a result back. And if I want to get West Virginia, I could just add West Virginia to that list. I'm picking all the redneck states in Ohio, by the way, or in the United States. Ohio is only partially a redneck state. It also has Cleveland in it. So, and here's the sinter command, the center command. And this will allow you to do a cross-key, cross-index queries. So if you want to get all the Bigfoot sightings in Ohio and that are a Class B, then you can get an intersection of those 2 sets, and now you're narrowing it down. And so this works fairly well, as long as your problems are simple. But it's got some problems. One of them is all these indices, because you've got to manage them, right? You've got to do all this code yourself. So, hey, I'm setting this, I can't just set the set to what I want it to be, or set the hash to what I want it to be. I also have to remove things when they change. So here I'm moving this sighting from Ohio to Kentucky, so I need to remove it from the Ohio index and add it to the Kentucky index. And then same thing for changing from Class B to Class A. So you got to maintain these lists along with everything else, which is not super painful, but it does have one other problem, which is it's not atomic. So you can run into this problem. The orange Merson, the orange meeple there, updates the Bigfoot sighting and says, this is no longer in Ohio, it's no longer Class B, it's in Kentucky, it's Class A. Then the green meeple comes in and says, give me all the Bigfoot sightings in Ohio. Well, it's going to get 8086 because the orange meeple hasn't updated the keys yet. So, A, you've got to manage these indexes. B, you can get a lot of them. Like if you've got a lot of values in your hash for that particular key, these can kind of float out of control. And they're not atomic. Now you could do a multi to make a transaction here, but then that adds even more complexity to what you're doing, and it starts getting into questions of clustering. So if you do a multi, all of the keys have to be on the same cluster in the same shard. And so it just gets messy really quick. And I can't do all the kinds of queries that I want to do. Some of them are easy enough. If I want to find all the Bigfoot sightings in Kentucky and Ohio, Ohio is the one on the top, Kentucky's the one on the bottom. Ohio is my home, and Kentucky is the home of that golden, delicious beverage called bourbon. Then that's easy enough. We just do a union on our two keys and we get it. Or on our two sets. What if I want to get, in addition to Ohio and Kentucky, I want to find Bigfoot sightings that are class B. All right. So I need to take the result of my union that I just did and then do an intersection with that. But there's not a Redis command to do that. And so you can do a set intersection against the class B index and then against what? Well, you could do the other comparison first. You could do a union on Ohio and Kentucky and create a temporary key, a temporary set, and then do that intersection. And that would work. But now you've got a set that you need to clean up, or you need to mark it for expiration. But either way, it's extra steps. The complexity keeps growing and growing. What if you wanted to get all the Bigfoot sightings where the temperature was 75 degrees Fahrenheit or higher? How would I build a set to do that? I don't know. You could probably use a sorted set and then, do like a range on that. But it's getting more complicated. What if I wanted to get Bigfoot sightings that had the word creek in them? Or as I say it back home, crick. What if I wanted to find Bigfoot sightings that were within 50 miles of Cincinnati? These are all the criteria for the wonderful encounter with my father when we stole the picnic foods. How do we do that? I don't know. He said rhetorically. Well, you might be shocked to find out, but the way you solve this problem is the third way that you can find data in Redis, and that's to use RediSearch. RediSearch is a module that plugs into existing Redis to add additional capabilities. It's like modules are like plugins. They're written in C or Rust or any systems level programming language. RediSearch is one that will do all this searching for you. It adds that indexing for you. It manages all this indexing for you automatically. It also provides full text search. So if you want to look at like text fields, like an essay or an eyewitness account of a Bigfoot sighting, and find the word creek. And it also does aggregation. So you can do basically group buys and say, well, I want to count all the Bigfoot sightings in a particular place, or I want to count how many Bigfoot sightings are above a certain temperature, or what's the average temperature of a Bigfoot sighting, those sorts of things. To start out with RediSearch, once you have the RediSearch module installed, and by far the easiest way to do that is to get Redis Stack. I'll have a link to that at the end, and it's what I'm running on my computer right now. But you have to create an index. To create an index, you call the ft-create command, and you give the index a name. You say, I want to index hashes, in my case. You can also choose JSON, and you can index Redis JSON documents. And then you give it a prefix. This is optional. But this is all the keys that are in the key space. If they start with Bigfoot sightings with colons, then it will be indexed. And if it doesn't, it won't. And then you provide a schema describing what your data looks like. And so your schema has got a name. In the case of a hash, it's just got the name of the field in the hash. It's got the type of data that you're putting there. Text, meaning full text, like human readable text. A tag, which you can think of as like a tag cloud on like a blog post. But they also make really good IDs. And they are also text. Numeric, which is exactly what you think it is. And geo, which is a location using latitude and longitude. And you can optionally mark these sortable, but not geo. So if you want to sort by the tag or the text, you can do that. So once you've done this, you can find all the Bigfoots by calling ft-search, give it the index name, and then your query. This is your index. This is your query. Now I'm using star because that returns everything, and it's the easiest query to show you the basic syntax of this command. But we'll look at the other things that we can put inside those quotes. We can limit how many results we get back. By default, it will give you the first 10, but you can set it, say, give me 5,000 through 6,000. Start at position 5,000, and then give me 1,000 items. So it's starting index and number of results. And you can specify which fields you want to return. You don't have to return them all. And so here we're returning just the ID and the state. And that number right there is just saying we have 2 arguments coming after the return statement. And then what you'll get back is a result something like this. If you're using the Redis command line tool or Redis Insight, you'll get the number of sightings back, and then the key it's stored in, and then all the fields that you requested. So here we're getting 4,586 Bigfoot sightings, and then they're listed off. Mississippi, Michigan, and Minnesota. I guess those are prime Bigfoot country. Sort of touched on this already, but there's 4 different types of fields: text, tag, numeric, and geo. We're going to go into them. Text fields, you just define them as text. So here I've got a sort of a shortened down version of that schema where we're creating a sighting index, and we're just taking the title of the Bigfoot sighting and the observed. To search text, it's actually the easiest of them all. You can literally just call FT_search, give it your index, and pass in the word you want to search for. And what that will do is we'll take any text field that's in your index, and if that word's in there, you'll get a hit. Space delimited gives you extra words. So this will find anything that has creek and river. Tilde will make one of them optional. So this finds any Bigfoot sighting that has the word creek, and if it has the word river in it, it will rank higher. Creek or river, and stream, creek or river, not stream. So lots of ways to slice and dice this. And if you want to actually tie it to a specific field, so say I want to find where the word creek is in the title, but the word river is in the observation in the eyewitness account, then you can use an @ sign and the field name and a colon to say, look only in this field. When you set up your schema, you can make your text weighted. So here I'm giving the title a weight of 2 and the observed a weight of 1. This means that for scoring purposes, words found in the title will be more valuable than words that are found in the observed text, which makes sense. And everything else is the same. You're just changing the order the results come back in. This is full text search, and so it knows what stop words are. These are the words that are really common in a language. These are the stop words for English that don't give you meaningful search results. So if you were searching on like the Bigfoot, the is going to be in almost any English document. I don't know that I've ever said a sentence without the word the in it, except maybe that one. Except I use the word the anyhow. So these are words that are ignored because they're not useful for search. You can turn this feature off. It's full text search. It also supports stemming. And so stemming is taking, it's multiple words that mean the same thing, but they're grammatically different, right? So like the word give, if you are searching on the word give and the document contains gives, give, gave, given, giving, those are all still the same word. They're the things we want to search on. And so RediSearch supports this out of the box. And it supports it for these languages. So that's full text search. And so I should be able to find all the Bigfoot sightings that have the word creek in them. So let's try that out really quick. How am I doing on time? I'm going long. Sorry, folks. So I have already loaded. I got a bunch of JavaScript code here to load up all these Bigfoot sightings. And so I've got JSON documents here, and I've got hashes. And I'm going to search the hashes, but we can just click on these here in Redis Insight and see, like, here's Bigfoot sighting 50123. Here's the weather, the longitude, the title, audio recording of possible screams, growls, and fight with a dog from the late 70s near Prosperity. If ever there were an American sounding town name, Prosperity would be it, wouldn't it? That sounds like it's from a Western, doesn't it? It's in Washington County. In what state is this in? This is unscripted. It's in Pennsylvania, Prosperity, Pennsylvania. Anyhow, let's go over here and do a search. So we'll do ft.search, and this is the Bigfoot sighting. I can type. And it's on hashes and the index. And we're just going to look for the word creek. So that matches 827 documents. I'm sure they're all delightful stories. While out trout fishing, that has the ring of truth to it. Family goes fishing to find a large, strange footprint. These are actually so much fun to read. My favorite word to search. Where I'm going to share this with you real quick. And I just think this is extra funny. Five. There's 5 sightings that have the word Walmart in them. There's another one. This one's a particularly funny one. Amish. I actually grew up in Amish country. I'm not Amish, obviously, but there's one of them that actually mentions the word Amish in it. It's let's go look at it actually, because I'm running late. I might as well get off on a tangent, right? Close that there. So one of the things you can do with Redis Insight is you can search for key names and then click on them and see them. Memory told of a mid-afternoon encounter along the Flat Rock River. And this took place in, this has to have taken place in Indiana. I was going to say Pennsylvania. This happened to me and a friend of mine. Class A, they actually saw Bigfoot. Yeah, good times, good times. So, cool. So that's just searching for text. You can do more than text. Whoops. You can do tags. So this is the tag search syntax. With tags, again, you're just doing ft.search, Bigfoot sighting index. And then with tags, you say at field name, just like you do for the rest of them. And then in curly braces, you put the value you want to look for. So this is going to find all the Bigfoot sightings tagged with Ohio. This is going to find all the Bigfoot sightings tagged with Ohio or Kentucky. And tags can be on there multiple times. Now, in this example, that doesn't make sense because a thing happens in a state or it happens in a different state, but the states don't overlap. But if you had multiple tags on a document, you could search for ones that have one or the other. And you might want to search for ones that have both, and that syntax is coming. And spaces are fine, usually. West Virginia works just fine if you want to find all the Bigfoot sightings in West Virginia. But if you want to find Bigfoot sightings with a classification of Class A, this quirky thing happens. A is a stop word. And so you have to escape the space so it views it all as Class A as one word. And so it's a good habit to escape the white space. So you can get away with it West Virginia, but it's a good habit to always do it. And then if you wanted to do, they need to be Class A and Class B, then you could use this syntax here. You just reference the field twice and give it 2 different values. So we can search for at state Ohio and at classification Class B. Let's see if we can narrow in on my my fun family memory. So we were looking for creek, right? And now we're looking for at state is Ohio or Kentucky. And at classification is Class B. And I'm going to break the rule that I just said that you should do.
Is it case sensitive?
No, it's not. You can make it case sensitive. That is an option when you create your index, but it's not case sensitive. It's a good question. We're down to 33. So we left footprints all over, so I know it was a Class B sighting. It was near a creek, it was in Ohio or Kentucky, so we're narrowing it down. I remember it was a warm day that day. It was somewhere north of 45 degrees Fahrenheit. So let's look for temperatures. So here we have numeric fields we've created. We want to search on a numeric field. We again reference that field, and then we use square brackets to provide the low and high temperature, the range. So this will find all temperatures between 60 degrees Fahrenheit and 75 degrees Fahrenheit inclusive. If you want to get rid of one boundary, you can do a positive infinity on the right, a negative infinity on the left, or you can just get anything that's a number. And if you want to make them exclusive, use a parenthesis there on the left of it. So this particular one would get greater than but not equal to 60 and less than but not equal to 75. And so our query narrows even more. I want to look for where it was 75 degrees or higher, so let's try that again. The delays in switching screens is going to kill me here. We got at temperature high. And we want 75 to positive infinity. We're down to 11. We can also search using geolocation. And geolocation is a little weird because of how you have to format the data. So Redis wants your latitude and longitude stored in a very particular way. And it's not as latitude and longitude. It's as longitude and then latitude. So to store a location in a hash or a JSON document for Redis search to be able to index, it needs to be in this format. Longitude first, comma latitude. I know everyone else says it the other way around, but this is how geosets do it in Redis, and so Redis search does it the same way as well. We have some mythology as to why it's that way. I have heard rumor that Salvatore, the guy who created Redis, is Sicilian. That's not a rumor, that's true. But that he, in Italy and Sicily, apparently they do latitude and longitude backwards. I don't know if that's true. I've also been told that GIS systems tend to use X and Y instead, and so it's mimicking that. Maybe the Italians are right, I don't know. I just know that I have to do it this way with Redis to make it work. So you provide the longitude and the latitude. To query on it, it's a lot like the numeric search. You use square brackets, you provide a longitude and then a latitude, and then a number of how much of a radius you want to search in, and then you provide units. I'm using miles here, of course, because reasons, but you can also specify feet, meters, and kilometers. And that will find everything that's within that distance of that location. And so I can use that to find Bigfoot sightings within 50 miles of Cincinnati. So let's go ahead and add that. And I'm not going to type that coordinate out. And I know there's no Bigfoot sightings around here, so I can't use a friendly local location. But I'm going to totally do this. There we go. That gets it down to 2. I think I could find that. Behold the power of search. Family goes fishing to find a large strange footprint. We read that one. Vocalization. Why are they all about fishing? I don't even like fishing. So cool. I'm close to finding my dad. I got about 10 minutes left here. I think I can get it done. So here's the script I just typed in that's putting it all together. Search for all those keywords, limit it, return the fields you care about. I've sort of done the demos as I've gone, so I'm not going to do that. But is that a great looking bike or what? It's a really nice looking bike. I've got a slide here. A lot of these queries I've done You may be used to thinking in terms of SQL or SQL. I know that I am. These are some SQL equivalents. This is just if you download the slides later and you want to reference it. It's a nice little reference to have. I'm going to talk really quick about aggregation. I've got about 10 minutes left, right? It says 11 minutes there. It's like they knew I needed to know. So aggregation lets you group things. So here I'm doing FT aggregate. I provide the index that I want to aggregate against, and then a query. I'm just going to use star for now, but any of those queries that we used in search would work here. So you could search and find things, and then in that set that you search, then do aggregations against it. Aggregations will allow you to filter values out, which works a lot like search. It will allow you to transform your values to take the fields that you have and create new fields. You can group them. So you say, well, I've got, group all these sightings by state. And I want to know like the average temperature of a Bigfoot sighting in each state. And you can sort them so you can get your output in a particular order. And these are not one-offs. You can do these in sort of an endless pipeline in a very functional way. So you could filter and then filter again and then group them. And then from that group, create a new field by transforming it and then group that newly transformed field. You can really kind of go crazy with this. Filtering works pretty much like you'd think it would, honestly. You filter and it's got things that look like the things you would put in if statements. So I want to filter where the high temperature is greater than 75. I want to filter where the humidity is greater than or equal to 80 or the temperature is less than 80. I want to filter out records so I see only where the humidity is greater than 50% and the humidity is even. I don't know why you'd want to do that. There are functions that you can call in as part of these. So you can say, does this field exist? Right? I only want to know. I only want results where there is a high temperature result in the record, or where I can modify that number and say, well, give me the floor of this for decimal numbers. And there's even date functions. If you have a numeric and it's a timestamp in seconds from the epoch, you can do day of week, day of month, that sort of thing. And so this gives me everything that's not on Sunday. There's a whole bunch of functions available. Check those out later. Transforms let you create new fields. So here we have the high temperature. So we're using apply, saying temperature high as high F. It's really hard not to say that without saying high AF. For what that's worth. But here then, all that's really doing is renaming that field. But then this one here, and these you could do these together. I could take the high temperature and convert it to Celsius, which might be useful for everyone else in the room, as high C. There are, again, functions that you can use to create new fields. So here we can create a field that says whether a field exists or not. We can get the month of the year, turns 0 to 11 like JavaScript does, and so you got to add 1 to it. And all the functions that we just saw earlier are the same functions you use for transforming these fields. I actually think the ones that are really neat in here is the date time ones are kind of neat, but there's geolocation ones where you can say geodistance, field that is a point, field that is a point. And I can create a new field where it's the distance between these 2 points, which means that you could then also filter on that and say, well, where these 2 points are within 50 miles of each other. So that's actually kind of a powerful search command. I just think it's kind of neat. I honestly just think geo stuff's kind of neat. Grouping, it's called group by, give it the fields that you want to group by, and then you have to select a reducer or an aggregator. That reducer is like something like count, which is just going to count the number of records in that grouping. So this would give me a count of all the Bigfoot sightings by state and classification. So 50 states, 3 classes, that should give us 150 groups. You can also return other things. Here I'm getting the average high temperature, the average low temperature, the highest temperature using max, and the minimum temperature using min. So I could get like the temperature range of Bigfoot sightings. And here's some, here I'm doing some other. Oh yeah, the point here is that you can do group by 0 and just group by the entire data set. So for the entire data set, give me the maximum temperature, the minimum temperature, and the median temperature. Here's a list of reducers. My favorite is count distinctish. If you have a really large data set, it uses a hyperlog log to do that with probabilistic data structures, which is a whole nother talk. Sorting, you can pass in sort by. It's really, and you can pass in ascending and descending. And that's pretty much what sorting does. It does exactly what you think it'll do. So I've got a couple fun queries to put this all together. I'm not going to go to the queries in detail, but I do want to look at the results of them because the data is fun. So this counts all the Bigfoot sightings by year and month. So how many Bigfoot sightings happened in January of 1980, February of 1980, March of 1980. And this is the result of that as a chart. I think this is fun because there's two things that jump out at you when you look at this data. One is what happened in 2008, between like the mid-90s to 2008, and what's that bump over there in the 70s? Now, I remember the 70s, and it was a weird time. And I think that was just sort of the spirit of the age. There's a lot of people that were high, and it was just kind of a weird time. And so I think that sort of reflects that. It was sort of a reflection of the culture of the time. Everyone is into Bigfoot and the paranormal and that sort of stuff. But in 1995, that's when the X-Files came on the air. And in 2008 is when it went off the air. And I mean, is that a coincidence? Yes. It's totally a coincidence. Actually, I think what the result of this is that 1995 was when the BFRO launched their website and started gathering the data that we're looking at. And in 2008 is when everyone had one of these in their pocket. And so someone said, I saw Bigfoot. And they're like, Pixar, it didn't happen. And so they didn't say they saw Bigfoot anymore. The other thing you notice on this chart, hopefully, is that it goes up and down. It's got some seasonality to it. That's because Bigfoot hibernates, of course, right? Well, let's find out. Maybe it is, maybe it isn't. So what months do Bigfoot sightings happen in? October is the winter. July, August, September are pretty good contenders. So Bigfoot sightings happen in the summer. And look, January, February, March, hardly any Bigfoot sightings at all. Bigfoot must hibernate. This isn't just people. Or is it? Right? No, this is totally people. My hypothesis is the reason we have these clusters in the summer is because this is when people are in the woods. So they can see Bigfoot. We have an absence of data. It's that whole absence of evidence is not evidence of absence. It's just no data. It's not evidence of presence either. It's just we don't know what's going on. Does Bigfoot hibernate? This data doesn't tell us that. This data tells us humans hibernate. The thing I think October is interesting because that's when the trees all lose their leaves. And so you can see the furthest in the woods. In North America, this is when hunting season tends to start too, so more people are out in the woods. I've got 1 minute-ish. So what might help with this is sort of reinforce this idea, I just think this is kind of fun, is the day of the week that Bigfoot sightings happen on. So notice that it's Saturday by significantly more. Who here likes to camp? No one will admit it. Okay, one. So when you go camping for the weekend, you go out for the weekend. And so Friday, you get off work and you've kind of been packing your stuff all week and you throw everything in your car and you go to the campsite and you set up tent and you make your fire and you get some food and then it's dark. And then Saturday, you get up and you got all day to be out in the woods. And then Sunday, you wake up and you tear everything down. What's the day that you would be in the woods to see Bigfoot? Saturday. So this data has nothing to do with Bigfoot and has everything to do with humans. And so I just think that's kind of fun. So I'm not going to demo this. I don't have time. Here's some resources to go check out. You might feel compelled to take a picture of that. It's basically go to redis.io, look for Redis Search, Redis Stack. The Bigfoot Field Researchers Organization's website is real. You can go out to bfro.net and check it out. The data set from Tim Renner is out there. Thank you so much, Tim, for putting this data set together. I've gotten so much mileage out of it. Is out there on data.world, and you can check out his blog with his conclusions, where I told you about at the beginning as well. All of this is out on GitHub. You can scan this QR code. It will never give you up, nor will it let you down, or run around and take you to some site it's not supposed to, as everyone slowly puts their phones down. And no questions. Check out our Discord server, Redis University, Redis Cloud, and thanks a lot.